Okay, I want to get started because we've got a lot to talk about. I'm excited to talk about this topic. So, trying to maximize the time here. So we're going to be talking about OpenCE, the Open Cognitive Environment. It's a brand new open source contribution, kind of originated at IBM. So we'll be talking about that, and then talking about and talking to Chris Sullivan, who's here with us as well. He's from Oregon State University. About his involvement in the project, and maybe we'll get your involvement as well. So, we're going to talk a lot about what OpenCE is, but I want to talk a little bit about the history as well, because we see where we came from, so we can find out where we are and where we're going to go. So, if you were on the keynote this morning, Mindy, the president of OpenPOWER was mentioning about PowerAI being open source, which is true, right? But there's IBM uses a lot of different terms, so let's just kind of make sure we all understand the history here. So back in 2016, IBM was looking at bringing GPUs to the Power Platform for the first time, and working with NVIDIA, and there was a lot of research going on and about workloads and things, and the PowerAI project came into being at that point where Google had just open sourced TensorFlow, and Caffe was out there for the first time. These deep learning frameworks, which were perfect fit for GPUs, and seemed a perfect fit for the Power Platform as well. Just all the data centric aspects to them. So, at that point, what the PowerAI was basically building these packages for the platform, making them available, and then investigating it. Turns out they ran really well there. So we wanted to offer those, to customers in a supportable way. So that's kind of what PowerAI was. It was like, okay, let's build these packages, make them available, optimize them for the platform as best we could, and bring them to market. And a couple other products sprang out from that. We had the Vision and PowerAI Enterprise that were all built on top of this kind of core PowerAI set of frameworks. When we brought that to market, we started to come in, how do we support these things? How do we, the upstream moves so fast, and then how do we support these and support our businesses that want certain versions of frameworks for 6 to 8 months or longer, right? Where an upstream's having a new version every 6 weeks. So that became our new problem, in more than just porting these things, because we did the porting, we upstream most of it. These are open projects. They're all, a lot of the changes that we need to do have been accepted. So what the project turned into was kind of like this continually built CI project, really. And it's kind of an interesting problem. And this is kind of what we're open sourcing today. So so we actually have the name for it was Watson Machine Learning Community Edition, was like the latest name of it. The PowerAI name is not being used like as a formal product name anymore. But so now we're moving into this OpenCE environment, Open Cognitive Environment is what we're calling it. So the idea here is to take some of what we learned on supporting fast-moving open source AI projects and bringing them to an enterprise and research level support. So your similar objective is what, like we do aim at living at this midstream kind of level in the OpenStream community. I'll illustrate this a little bit better on the next chart. The midstream is an area that where Red Hat plays a lot in, where the integration happens in the open, and then your downstream is your product level, and that's your support and your security fixes and your updates and whatnot, right? So having this, there's a lot of collaboration that can help the integration level. So focusing on the midstream is really kind of what we do in a lot of this this PowerAI environment.
Can I mention the one piece, which is that this PowerAI really provided these optimized pipelines to the end user in a way that enabled them to focus in on their work and lower their activation energy, and that IBM really did listen to the community while we were doing this, and that's the evolution history you see on the right-hand side. But
yeah, thanks for mentioning that. That's one of the other foundations of what we did in the project was, these frameworks are heavily, influenced by the hardware they run on. They're GPU enabled. We want the most optimized hardware builds, possible. And all that's very hard to do. Like, it's like we want running on x86, we want the best optimized version of that for the hardware we run on. The same thing on power, and we want it easily consumable and easily usable, right? That's one of the foundations of the project as well. And we don't want people to have to worry about that, right? So, and then we'll talk a little bit more about why we do it this way instead of just relying on pip and stuff and upstream as well. So what it comes down to, though, is providing this flexible source to image kind of solution. And what I mean by source to image is, taking the power of the binaries back, right? So in order to give you the power of control of what you're actually running, as far as optimization, as far as fixes, as far as updates and whatnot. So let me illustrate a little bit more on what we mean by midstream here. We have, if we're looking at like a TensorFlow or a PyTorch, obviously we've got the upstream open source projects that are, mostly run by Google and TensorFlow, but there are open contributions as well, especially when it comes to hardware, right? We on the Power team, we put a lot of the updates needed to get these frameworks to work in the upstream little box there. But what we found when we were doing a lot of these, doing this initial enablement, is these AI frameworks have wildly complex dependency chains. So TensorFlow itself, I think, has 87 open source projects that it relies on. So, building that once and shipping it out the door, okay, you can do that. What about keeping 3 versions of it in support, both with security fixes and, just functional fixes? It becomes a difficult problem, especially with all the dependencies that it relies on, and then add PyTorch to the mix, which is also wildly complex. How do you have those all those dependencies work in the same environment together? And that's what we wanted to do with PowerAI. We wanted like ease of use, just hit go and you get all of the AI frameworks into a single environment. Where does that integration happen? So that integration happens in the midstream, and it does make sense to kind of move this to an open model where all the different people that have needs on this type of thing can have input on it. Like, which version of TensorFlow do we want, and then which ecosystem packages around it do we want to include in this environment that we can pre-integrate and then click a button and build the environment and put it into production. So that's that's kind of the model here that we're moving towards, and in this what also we mean by this source to image kind of model, right? Is which with the advent of or the popularity of hybrid clouds, when people maybe have a large OpenShift cluster on site now, we want to target to be able to leverage some of these resources, both in a hybrid cloud or out in a research institution like Oregon State. Just click a button and get your pre-integrated set of packages in a coherent cognitive environment. So another key piece of this is the hermetic builds. We want to be able to have this build the same way no matter your environment. So that's a big piece of it. And today we leverage Conda. Conda is really good at that. And there's a couple of reasons to use Conda I'll get to in just a second. And then but the end result is a standardized set of content and versions for the community, to use and to kind of standardize on. Like, all this stuff moves so fast. If you need something like Hugging Face transformers, which is a very advanced set of models for natural language, right? And but you also need a certain version of TensorFlow. Which versions do I pick, right? So, and what about all the other dependencies that are involved with that? Now, that integration can happen right here in the midstream. You get involved in this project, And we can get that integration out of the way, and we can get down to business and actually doing the research, right? So that's part of the other tenet of this project. So I mentioned Conda. I think there's a couple charts here on why we're doing some of the technologies that we picked. We did pick Conda in PowerAI. It's our multi-architecture by default, but it's kind of not the only way. The only reason. One of the other reasons is if relying strictly on wheel files in the Python community has a lot of limitations to the whole environment of wheel files and PyPy. They're getting better, and part of why they're getting better is there's communities like TensorFlow that are outstripping the capabilities of pip and PyPy and are pushing the community forward to be able to include things like basic metadata for CUDA, or even like what kind of basic foundational libraries that you rely on, so it's compatible. But with Conda, it's already kind of all baked into this, baked into the tool set. There's a separate tool chain that Conda uses. It's hermetic by default, and it's easy to easy to use. And then there's also a real solver, dependency solver that's built in where pip does not. So another chart here, just kind of underlying the fact that on Conda being the initial first direction for us, which isn't to say that it's not possible to do wheel file builds. With OpenCE, we can certainly add that, especially if there's people in the community that wanted it. It'd be great. We'd love to work on it. It's just that Conda is just so much further ahead in the community as far as that goes. So yeah, so things like the mini Linux standards and pipenv and some of the new things that are coming in the Python community environments are all good things to track, and we will be looking at that as well. Red Hat has a project called Thos Station that is also a sourced image kind of builder focused around PyPy and wheel files, and that's something to watch as well in this environment. We'd love to integrate with that at some point. Okay, so that's why we do Conda. The benefits of an open approach, I think, are pretty obvious. We're all on OpenPOWER here, right? So we came here to learn about open things. How do we work together? How do we collaborate, right? But the fact of the matter is, open communities can move faster. They really can. So the speed at which these upstream communities move at is impressive, right? We need focus from all over to be able to keep up with that, right? And so that's definitely an open community moves faster kind of story. The content as well, right, is good to farm out in an open way, right? If we have a singular focus on the things that IBM wants, for example, with PowerAI, it's like we knew what we wanted with it. We use this stuff internally as well. That's great. We can get it in. But what about the 6 other things that are needed by a customer over here and a research environment over here? If this was an open collaborative environment like we're trying to do with OpenCE, then that could just be added. You can either add it to the community, or you take it out and you add it yourself as you build it, right? So just the general community set direction, especially in the midstream where we're trying to do this collaboration work, makes a whole lot of sense, and it even makes enterprise support downstream easier, right? The most expensive part of a life cycle, of a software life cycle, is that downstream, support, where you're interacting with customers and fixing their problems, and have boots on the ground kind of thing if something goes wrong. So you need it to be as good as possible, and you need it to be as fast as possible, and you need it to solve everybody's problems, right? So yeah, so and just general usage freedom, right? you want the function that you want the fixes that you want, when you want it, how you want it, right? So, and that kind of, goes to the, back to the point of why Conda, or why we do this at all, actually, right? It's part of part of the reason is control, right? So if we rely on packages from pip, which are pretty great, by the way. Google puts stuff out there really quickly for TensorFlow, for example. But at the same time, they security patch it when they want to. They support certain versions that they want to, and they build towards hardware that they use, right? So TensorFlow actually supports a lot newer version of the Intel, vector instructions, for example. With Power, there's a little bit less variety, so we can kind of control a little bit more when we build there, although there is no pip packages for Power too. That's the other problem. But a lot of people build TensorFlow themselves, even on x86, because they want to take advantage of their hardware, right? So that's the other thing, to take advantage of the hardware that you have, but also be within a community and a project that will make it work, right? And if you build it yourself, you're on your own. As far as TensorFlow is concerned, we don't want you to be on your own. We want it to be a collaborative community where we can build all this together, have it work, and have it work the way you want it to work.
You've got about 10 minutes left before questions.
Okay, perfect. So let me do just the content here, and we'll kick it over to your charts, Chris. So the stuff that we'll include is obviously the TensorFlow and PyTorch ecosystems. I think each release of OpenCE will have like a new version of each one of those, and then whatever else we kind of happens to be there at the time as far as versioning. We'll also include XGBoost, and then things like Spacey, and then I mentioned transformers from Hugging Face. We're going to include that as well. We'll have a set of Docker files that'll spit out from this, in addition to the Conda packages, and then we also have a complete set of CI and pipeline targets for building this stuff, right? So we'll have a complete local build set up, and then we're working on a Argo Kubernetes native CI environment where it'll take a dependency graph output from the basic scripts, and then it'll feed into a Kubernetes Argo setup and build everything in parallel. So this, which kind of really brings this source to image project kind of alive, right? You can, these stuff takes a lot of time to build, but if you have the power of a, multi-node Kubernetes cluster that you can, constantly keep at high utilization by building the stuff as you need it. So there you go. That's another piece of the value there. And that's just kind of underlying the CI piece here. So multi-platform is the goal. We have a power heritage, but a big piece of the value here is, support for the hardware that you want, right? So, and you need. Okay, so Chris, let's hop over to you. We can introduce how Oregon State University is going to be involved.
Great. So I know there's something in the chat there. You have 10 minutes remaining. All right, so Oregon State University is one of these downstream groups that was leveraging the PowerAI system. And I wanted to give 1 second about the background on why we do this. Oregon State University has, first and foremost, what we call the open source lab. And this group is out there helping open source software stacks become more accessible, get people involved in them, and provide access. And so we're already doing that for about 160 projects. Lance Albertson gets credit for that. He helps manage that through the campus and through the campus School of Electrical Engineering. And things like the Apache Software Foundation, Drupal, all kinds of stuff are being hosted out of Oregon State University. And we have a large OpenStack cluster that OSU manages with Jenkins, and all the tools ready to go for users and continuous development to occur. The group that I'm part of is called the Center for Genome Research and Biocomputing. And we're really one of those research groups that takes advantage of this technology and leverages it for research purposes. And one of our main focuses is to take technologies and integrate them in a way that reduces the impact to our researchers. And PowerAI really did that for us. And we work with a large group of users across almost every single department on our campus. And one of the things that we bring to the table is the ability to interact with these GPU technologies. We've been compiling software stacks for many, many years, and we've been able to show the value of the multi-architecture infrastructures. Jason, can you switch the slides for me? Thank you. So really, when we looked at this opportunity, we saw that there was already a pathway in place, and we wanted to help take over a piece of that pathway and kind of stick ourselves in the middle. There were the upstream releases. We kind of called it at that time the Wild Wild West, uncoordinated. And really, that's where things should be for a lot of developers, testing and making things kind of change and come to life. And then ultimately, there's this, midstream. And the midstream is where we're going to kind of put things back together and try and create these releases of this upstream technologies. And we're really looking at how we can put those releases in a way for the community to be involved and actually work with us to actually get those out. We'll be looking at how we can release these under initially a single TensorFlow and PyTorch release. I think that that's an important aspect of this, so that way we can focus in on the functions and the capabilities of those functions and making sure that we're doing things cleanly and that we're getting all the optimizations that we're looking for. In the end, we are going to be including, as Jason said, pipelines and all kinds of other things. But we're also going to start looking initially at a single version of CUDA. I think that the community involvement will help us broaden and create a vast different other areas around that, and maybe more versions of CUDA. But the Oregon State University capabilities will first look at one version of CUDA, and we're going to try and focus in on that as those stable releases of those other technologies, Caffe, TensorFlow, PyTorch, come out. Can you go ahead and change the slide for me, Jason? So we are going to make an official statement that Jason helped me create, which is that we are announcing the intent to build and offer community binaries related to each one of those tagged releases of OpenCE. And that's in an effort to grow participation. And we really are looking for groups to get involved with us, and we're going to create a pathway for them to get involved with us. It's important for us to make sure that those binaries are in that Conda space and are maintaining that multi-architecture or heterogeneous architecture set, which is x86 and right now PowerPC LE, which is really what we see a lot of the high performance computing being focused in around. We hope that people are going to be helping us contribute. We also hope that groups like IBM will be able to take the midstream and create a downstream solution still for their needs, and other groups potentially be able to do that as well, maybe cloud services. Being able to put this into this context allows us to move at our own pace. And I think that that's what I was trying to say at the beginning, was that IBM was listening to us. And that's what you saw over the years were the changes. And this, I think, is our next logical step with this technology, is to kind of bring it to the community and let the community take control and drive its future pathway. What we wanted to do at the end here, Jason, was go ahead and show some of the examples. And here's some of the usage examples that we have. Build an individual feedstock. And this is where we're going to have these capabilities to basically build out these environments very quickly and very easily, and get the community involved and get people able to help us get this work done. Jason, did you want to help conclude this for us?
Yes, right. And the kind of the interesting aspect on this chart is the flexibility here, right? If you wanted to just rebuild a piece of the environment, for example, you can build individual feedstocks, which is the Conda terminology, versus building an entire TensorFlow environment. What that is not only TensorFlow, but like its dependencies that are needed, that are either pulls in through various channels. You can see here we're sourcing the actual WMLCE channel that's for CUDA at the moment. But that'll build out the entire environment and all the dependencies. You don't even have to think of what it is. It's already pre-integrated, preset. And then, build all of OpenCE releases, the one on the bottom, where we'll not only build the TensorFlow environment, build the PyTorch environment and the XGBoost environment, and its dependencies based on the dependency trees that were created during the analysis step. So
we have one question. The question is, when can we expect the first OpenCE with CUDA 11 support release?
So yeah, I think good question. So we're initially still targeting 10.2, is mostly because the scripts that we had internally were 10.2, and we wanted to have an external version of that. That and upstream hasn't moved to CUDA 11 just yet, and in a tagged release. So TensorFlow just, I think last month they had a whole bunch of commits that were in for CUDA 11 finally. So we'll be able to benefit from that. We'll kind of just follow. I mean, this is an open thing. We'll follow where upstream is, if the support is there, and we can always help in the upstream, but it's primarily a midstream kind of project, right? So we'll follow where upstream is on that, and it looks like they are there for CUDA 11. So our initial release will be at CUDA 10.2, but probably sometime by the end of the year we'll have ratcheted up to CUDA 11. Support in there as well, and and as Chris mentioned, maybe we'll at that point add in another switch here where it could kind of build for multiple CUDA environments if you still needed the 10.2, for example. People don't always move up to the CUDA latest CUDA that is available, so it'd be nice to have both, right?
Hopefully that answers our question. If there are any other questions, we can take some of those for you right now. We have just a couple minutes left.
Yeah, and while we wait for some, I switched to the last here, the page here. We've got our GitHub link. Head out and take a look. Give us a star if you want. Watch where we're going with it. We have code out there now. We don't have the CI code, the Argo code out there just yet, but we do have all the local scripts. So you should be able to build up an entire TensorFlow environment or entire OpenCE environment out of the box if you'd like. We're still working out some of the kinks with the open version of stuff, but love to have your feedback on it and your involvement, right? As we mentioned, I think this will be as good as we can make it as a community.
I don't see any other questions right now, and we're just about out of time. We've got another minute or so, I think. So anything else you want to finish with, Jason? I think that we're excited about you helping us transition into the space, and we'll probably be picking up that 10.2 release to begin with, but we'll be working with you on that 11. So
yes, yeah. I think that'll be an interesting step there. Is moving this from primarily IBMers working on it to IBMers working on the open to a community working on it, right? And we'll evolve it as we go. I think there's interesting direction here on taking the dependency graphs that we've have built in the early code, and what else can we do with that as far as integration goes. We've got a lot of ideas. We want to develop those out in the community, and really make this a valuable addition.
One more quick question: how additional packages can be included in OpenCE? How the process will be done? For example, OpenCE 4.x.
That's a good example. Yeah. So we, if you wanted to add a new feedstock, well, for one, we have we're working on the CLA out there now. We've got to get a lawyer stamp on it and some approval. So right now you'll have to open an issue, and we'll have to do it. But soon we'll have that worked out, and we'll have community involvement on that. And you'll be able to just add a PR to it. And eventually we'll have a little bit more checks and linters and that kind of thing that should be able to check it out and make sure it's a good feedstock. We're not aiming this to be another Conda Forge though. Keep in mind, it will have to be an OpenCE is a good example to have in an environment. It's a lot of integration points and a lot of integration pain come with OpenCE, right? So that'd probably be a good one to have in there. But but we won't just have anything in there, right? So it will kind of come down to a certain approval from the team or from the community in general about like what we want in OpenCE. You know, what do people need in their cognitive environments, right?
There can always be downstream scripts to help people integrate.
Exactly, and you can always fork it and add it yourself, right? If we determine that you know, we don't want to take that one on as a group.
I think we're about out of time, so I don't see any more questions.
Okay.
All right.
Thanks, guys. Thanks, Chris. Thanks everybody for joining. This was great. I'm excited to talk about this today, and hopefully we'll see you online.